Hi, here's the second part of machine learning tutorials. I'm Deshani Geethika from Sysco LABS R&D Team. In this tutorial, we are going to give you an idea of how to apply machine learning theories into practice to solve an actual machine learning problem. So let's start. So for this session, I have selected a dataset from an ongoing online machine learning competition, and we have changed the dataset a little bit for this demo. So talking a little bit about this dataset contains details about medical records of people, and what we have to do is we have to predict whether these people have heart diseases or not. So we are going to solve a classification problem, and this is a binary classification problem. In other words, we are going to predict two classes, yes or no. So for this session, for coding purposes, I am using Jupyter notebooks. Jupyter uses IPyNB notebook documents. So these documents are used for interactive development. So let's start. First of all, I have imported Pandas library. Pandas library is for data analyzing in Python. So let's run it. Then after importing it, the first thing we have to do is we have to read the dataset. So our dataset is in data.csv file. So from this command we can read the dataset and assign it to a variable called df. So after reading the dataset, we can load it and see how it looks like. So from this command we can see first few rows of the dataset, and we can tell the number of rows required kind of things. So as I have mentioned, in our dataset there are features for different kinds of medical records of people, and what we have to do is we have to predict this target variable whether it is 1, that means the person is having the heart disease, or otherwise 0. So I will mention some few commands you may be required to get to know about the dataset. The first thing is df.dtypes. From here you can see the types of the data types of the each columns. Then from df.shape command you can see the number of rows and columns of the dataset. Then from this command you can see some kind of statistical figures of the dataset, like standard deviation, minimum, maximum kind of things. So keep in mind that you may require these commands. So now we have done reading the dataset, and we have played with the dataset little bit, and we are going to move into data visualization part. So data visualization is very important in machine learning problems because we need to identify the behavior of the features, individual features, and we need to see how they depend each other likewise. So this step is very important. So first I have imported some libraries required. Then actually here I am using different kinds of plots that we can use for visualization, but keep in mind that there are lots of other plots and other libraries too, so you can play with them and find out what are the best plots required for your use cases. So the first plot I have chosen is just a simple histogram. From there one feature like Talash, this is the plot of that feature. So this shows the number of people with each Talash level. So the next plot is a count plot. So here there are two colors. From blue color it says the people with the disease, and green color it says the people who don't have disease, and here are the each age levels. So another type of plot I am covering is scatter plot. So from scatter plot we can see two features, like here what are the dependence between two features, and there are some outliers here likewise. And when the scatter plot is not working, like in this situation, we can use swarm plots. In swarm plots we can see these points are distributed like here. And another thing is box plot. box plot is one of the famous plots in data visualization. So here we can see the levels of Thalage levels for people who don't have the disease and have the disease, and with two colors, males and females. So from this graph we can see the levels of Thalage of people who don't have disease and have disease. And another type of plot is violin plot. From this plot we can see the distributions, each distributions of Thalage levels of males and females with two colors of people who don't have disease and have disease. So I have covered different kinds of plots there, and please keep in mind that, as I have mentioned before, there are lots of other plots too, and you have to select the plots that you required for your use case. With that in mind, we are moving into data pre-processing tasks. So data pre-processing is very important in machine learning because we get data from different sources and we can have missing values, outliers and noises. So therefore we have to handle them and make the data set fit for the model. So there are several steps in data pre-processing. We will go step by step. The first step is handling missing values. Actually, handling missing values should be done before data visualization, because if you have null values in your data set, you can't visualize them. But in our data set, we didn't have any null values. Therefore, we discuss it under here, but please keep in mind that you have to check that before visualization. So first of all, we have to check whether there are any missing values in our data set. So from this command, we can see each column with number of missing values. Like I have mentioned, we don't have missing values in our data set, but if you have missing values, you have to handle them. So the easiest way to handle missing values is just drop the missing value columns. So from this command, you can drop the missing value columns and you can actually define a threshold like this. So, but keep in mind that you can remove these data points only if it doesn't affect to the data set. If you have only few data points with null values, and in such situations only you can remove them. Otherwise you have to find methods to fill those null values. So if you can't just drop this null value columns, you have to fill them, and for filling null values there are several methods like ffill. What ffill does is, ffill will fill this null value column with the next value, and you can use other methods like bfill, and from bfill you can fill the cell value with the before value, or otherwise there are some methods like you can fill the null values with the constant value likewise. So there are several methods to fill null values. So with that, we are going into the next step of data pre-processing, that is outlier removal. For outlier removal, there are lots of ways to do, but I am covering only two ways. The first thing is using Sysco approach. So I have imported some libraries here, and here's the scatter plot of these two features. From this command, what it does is, it will remove the data points which are 3 standard deviations away from the distribution. So you can see now our data, there are 3 data points reduced. So if you plot the scatter plot, you can see these 3 points are removed. So you can change this threshold value and see what are the data points removed from the data set. So the next approach to remove the outliers is using quantile approach. So from quantiles we can define quantile levels like 0.9, 0.98, 0.7 likewise, and from that what it does is, it will keep quantiles up to this level and remove others as noises. So here, after the removal of the outliers from quantile, so you can see it is reduced like 266. So I have covered some approaches for outlier removal. Next I am going to cover encoding categorical variables. It is the next step of data pre-processing. So if you see our data set, it has sex in strings like males and females, but we can't go ahead with that. We have to encode them into ones and zeros. So we can do it in manual rules, but sklearn has made your life easier by providing a library for that. So if you run this, you can see the sex is transformed into ones and zeros. The next step is data normalization. Data normalization is done in some situations where one column is in one range like 1 to 10 and another column is in thousands range like 10,000, 20,000 kind of things. In machine learning, most of the models require to have every features in the same scale. Therefore, data normalization is required. So from here, so if you can see the data set, so these features I have selected 3 example features. So these features are in different kinds of ranges. So from min-max scaling, we have scaled all of these features into the scale of 0 and 1. With that, we are switching into feature engineering and Isham will continue from that.
Hi, I'm Isham. I'm from Sysco LABS R&D Team. So now I'm going to continue from the feature engineering and machine learning model building part. So basically feature engineering and model building parts are iterative process. So it's very highly unlikely for you to build a feature engineering part and then build a machine learning model and be done with it. So in most of the time what we will do is we do a feature engineering, we build a model, and then we again do the feature engineering to improve the features to increase the accuracy of the model. So today I'm going to cover some of the feature engineering techniques. So as you can see, most of the time feature engineering depends on the problem you are trying to solve. So for example, we can have 2 features, length and width, and then we can generate a new feature called area, which is a multiplication of length and width. So that's a feature engineering. And also let's say we have 2 features called temperature in Fahrenheit and temperature in Celsius. Removing one of the feature is also a feature engineering. It can start with such basic feature engineering and goes up to all the way up to using clustering algorithms to introduce new features, or we can use principal component analysis as well. So as you can see, feature engineering highly depends on the problem you are trying to solve, but there are some of the techniques we can use in most of the problem. So today I am going to discuss about few of them. So we start with the correlation analysis. So most of the time when we do machine learning problem, correlation analysis is a good insight of what we are trying to do. So this is a correlation heat map. So what's correlation? Let's say you have 2 features, x and y. When y increases when you increase x, and when y decreases when you decrease x. That means those 2 features are correlated. When we say they are highly correlated, that means you can derive y from x. So that means we have high correlation between x and y. We can also talk correlation in, we can say there are inverse correlation. When we increase x, the y decreases. We call it's inverse correlation. So that's basically a correlation. So we can use correlation in our advantage when we doing machine learning problems. So there are 2 significance of using correlation. One is to remove features, and also we can use correlation to add features. So let me explain what I mean. So most of the machine learning model, most of the time when you build machine learning model, we have to remove redundant features as much as possible, because in some cases it even affect the algorithms we use to minimize the cost. So it's always a good practice to remove redundant features. So we can identify remove redundant features by looking at this correlation map. So if 2 features has high correlation or high inverse correlation, so inverse correlation are basically denoted in negative sign. So if you have a high correlation value, that means those 2 features are almost identical. So when we say high, we can think of the threshold of 0.9. So if you have a 0.9 or higher correlation, that means those are identical features. So we can remove one of them. And also when I said we can use correlation to add new features, that means what we are trying to solve is to predict this target. So let's say if you have a feature which has a really high correlation with this target, that means we can derive this target using that feature. So it's highly unlikely for you to get a feature which has a high correlation with the target, but there are a situation you can have features such have correlation like in range of 0.5, 0.6. They cannot alone predict the target, but collection of those features can help you predict the target in a better way. So what we can do is to use correlation analysis and select some of the features which are very highly correlated as main features. So if you have a few features, 10 to 100, 10 to 50 features, what you can do is you can simply look into this heat map and find which are the features, which are the redundant features and which are the important features. But if you have features in, let's say, in 100 and 1000, it's not possible for you to look into this map and identify it. So what we can do in those type of situation, we can use this automated function. So you can go ahead and pause the screen to see the function in detail. I'm not going to go through the implementation detail. So this function will take all the take this matrix and cross-validate the correlation between every features and every features. So, and if you have a high correlation features, it will give you a list of features which should be removed. So let me load this function, and then I'm setting this correlation value as 0.7. So as you can see, we didn't remove any columns. That means we don't have any features which are correlated, highly correlated in the threshold of 0.7. So if you try to print this, so now this set is empty. So for the sake of this demonstration, I'm going to set this correlation as 0.4. If you can see that these two features should be removed in order to remove the redundancies between the features. So again, 0.4 is a bad choice of correlation. What we usually do is if you have so many features and you barely want to remove some features, we simply set this to 8 to 9. So 9 is a good threshold if only you want to remove the exact redundant features. So we don't drop any features in this case. That's how you remove features using correlation. Let's see how we can add features. So I'm again using this correlation matrix. So what I'm going to do is to plot these highly correlated features first. So what I'm trying to do is we take this target column. So the correlation is a matrix. We take only the target column, and then we are going to see what are the highly correlated features with this target, and then we are going to choose, let's say, only 5. So it's always good practice to start with minimal features. So when you are starting your machine learning problems, I recommend you to go ahead and only use these 5 features and then see how the model behaves. Later then we can introduce new features to increase the accuracy. So this is how we choose some of the best features. It doesn't mean other features are not important. So what it means is these features, you can focus more on these features. But there is one problem when it comes to categorical variable. So when I defined the correlation, I said if x increases with y, then they are highly correlated. But when it comes to categorical variable, let's say in this case we have something called CP, which is chest pain. So it's 1, 2, 3, 4. It doesn't mean those are like the levels are increasing manner. Those are only categorical. So when I say 4th category of chest pain, it doesn't mean it's always higher than 3rd category. It always depends on how I encode the chest pain. But when we plot this heat map, it considers those 4 as a higher value and 3 as a lower value. But when it comes to categorical variable, it doesn't make that sense. There are some advanced technique in statistics to find correlation between categorical variable. But what I am going to introduce you is a very simple technique to use a very simple machine learning algorithm and build a simple model and see how it behaves. So most of the time I start with random forest classifier. So the reason why I picked random forest classifier is it's very robust to the noise, and also it's an ensemble. So it's a collection of decision tree. So it's basically robust to the noise. So what I'm trying to do is I'm trying to build the random forest model and see what are the important features. When it comes to decision tree model, the important features are select based on the entropy. So if if selecting one feature does a good deviation in the tree, that means that's an important feature. So it's a collection of important features. So this is a good insight on what are the features can play a good role. So as you can see, it's not that different from our initial plot. So as you can see, CP is there and all peak is there. So most of them are same, but depending on your problem, these two can be totally different. So that means either you can choose these features, or you can choose these features, or what you can do is simply you can include both of the features. Okay. These are some of the technique we use to filter the features, and let's go to the next technique, which is introducing dummy variables. So as you can see, if I say df type, it says sex, the gender as an integer value. That means it has taken 0 as a lower value, 1 as a higher value, where it doesn't play that type of role when it comes to gender. So 0 is one category, 1 is one categorical. So when we say this as integer, that means 1 is higher than 0. So that's not the case. So what I'm going to do is I'm going to convert these categorical variables as objects, and then we are going to label encode. Okay. So as you can see, we have introduced new features, and this means now this is taking this as binary, that means true or false. So if you have 4 type of chest pains, so it says whether this is the second type of chest pains, this is the third type of chest pain, this is the fourth type of chest pain. So we are ignoring the first type of chest pain, because if it's 0 in these 3 cases, that means that should be the first type of chest case. When we generate dummy variables, it's always a good practice to eliminate the first column, because it's again going to introduce you redundant features. If we have sex 1 and sex 0, whenever the sex 0 is 0, the sex 1 is 1, and vice versa, whenever the sex 0 is 1, sex 1 is 0. So those are highly correlated features, and those are redundant features. So we have to always keep in our mind that to drop these first columns. So I'm not gonna add this to my pipeline. So now my data set is the exact same one before I did the feature engineering. So now let's look how we apply models. So when it comes to machine learning, applying to a model is one of the easiest parts, because of course models are complex, they have complex algorithm and data structure, but these libraries had made ourselves easier by providing the implementation. So we just have to call these libraries. So before we apply for machine learning models, we have to split the data into 2 parts. One is the training set, the other one is test set. So we will train our model using this training data set, and we use this test data set to validate our model. So when it comes to splitting the data set into train and test, we have to keep in our mind that it randomizes this data set. So if we have a dependency between the data set. That means if the data set is a time series data, that means the previous and the after data entries are related to the current data entries. So in those cases, we shouldn't be randomizing those data set to split the train test, but in our case these are just samples, those are not related to each other, so we can always split them by randomizing it. So what I have done is set 20% of the data as test data and 80% of the data as trained data. So I'm going to run this, and as you can see, by looking at these indexes, it's randomized. Okay, so again I'm gonna apply the random forest classifier. So you can see a very high accuracy here. So our data set is fairly small, so it takes no time to build the model, but most of the time you will be having up to, sometimes in a typical machine learning problem, depends on the domain, you can have up to million data set or even tens and hundreds of million of data set. So in those cases I advise you to use clusters to train this model, but since the data set is really small, even in my local computer it takes no time. So because of that, I'm gonna show you how we can apply all these models. So it's just a simple for loop, and then it applies every single model. So we have logistic regression, decision tree classifier, and gradient boost. So these are some of the classification algorithm. So you may have a question like what's the model I should use. So my suggestion is to go through this model and what they are trying, how the implementation is done, so and then see if it fits your problem. Okay, so whenever you apply a model, you should always know what's happening under the hood. You can't just call a library and think that everything would be fine. So you should always go to this library implementation and check how this is implemented, what is the mathematical model behind these algorithms. That's how you can get a good insight of which algorithm we should be using, and also that's a good practice for someone who does machine learning as a profession. So when it comes to building the machine learning models, there is something called hyperparameter tuning. Hyperparameters are the parameter you set when you before you build the model. So if you don't set any hyperparameters, it's always take the default model, but it's always advisable for you to choose the best parameters because it makes a big change. So let's say the difference when you set the number of trees as 200, or you can even set the number of trees as 5. So this makes a big difference. So depending on the size of your data and the type of the machine learning model you use, the hyperparameter may differ. So if you have a good domain knowledge and if you know what's happening under the hood of these algorithms, you can always choose the hyperparameter. But if you don't have such knowledge, what you can do is easily put all the possible hyperparameters and see what is the best. So it's a greedy approach, so we call that grid search. So let me again import the random forest classifier. So what I think is I have set a range of number of estimators for the random forest classifier and also the range of max depth. So by giving these as hyperparameters, I'm going to build the model with 36 combination. So I'm going to build the model 36 times and I'm going to see what is the best accuracy we got and fix that as a hyperparameter. Since my data set is really small, so it takes only couple of seconds, but if you have a large data set, grid search is not a good choice for you. What you can do is you can do randomized search. So in that case, it only picks random value and try to identify the best. So it's not a deterministic approach, but it works most of the time. So you can use random grid search. in this case, it says make the best estimators are 100 and the best max depth is 5. So I'm gonna run this model by using these parameters. As you can see, the accuracy is being decreased, so it's an interesting case here. The problem here is the number of data set. So we have only very few data. So one of the key thing you have to keep on your mind when you use random forest classifier, it's highly randomized, and every time you run the model, if you don't have enough data set, it might give different accuracies. So let's say if your data set is like if you have around 100,000 data set, that means the random forest classifier can work better. So this is how you do a grid search, and this is the matrix. So next we look how we evaluate our model. So it's not always the accuracy we should be focusing. We should be focusing on different type of matrices, depends on our domain, depends on our problem we are trying to solve. So as you can see, there is something called precision and recall. So what precision is, out of positive we have selected how many of them are actually positive. The recall is how many positive we have selected out of these positive. So those are two different things. Depends on your problem. We should select whether we are focusing on precision or we are focusing on recall. So let me give you a quick example. Let's say we are going to identify the patient. Let's say we are going to identify these patients with Ebola virus. So it's very critical for us to identify every single one, not leave anyone out. So in that case, we are going to increase our recall. So we are going to identify every Ebola patients as much as possible. So as you can see, there are different type of situation we should be focusing on precision or recall. It's not always the accuracy. So when we do the evaluation of the model, you should always keep in your mind that you shouldn't be always looking into the accuracy, as I said. So when it comes to classification, these are good matrices. The confusion matrix is a good type of matrix to look into it and see how your model behaved. When it comes to regression, we can always use mean square error. That's also a good measure. So with that said, this is some of the technique we used during we built the model. So we covered such as some of the feature engineering techniques and how we use correlation to our advantage, and also we cover how we apply machine learning models, how simple it is to use a model. But the critical part is to understand what's going under the hood, because if you blindly try to apply models, it's not going to work, or even if it works, you won't be able to tell why it works. So I advise you to go to the websites and see what are the implementation of these algorithms. And also we saw how we do hyperparameter tuning, so the significance of doing hyperparameter tuning. And also we saw how we evaluate our models, what are the techniques we evaluate the model. So with this knowledge, I am pretty sure you can go ahead and try out a problem. So these are pretty basic stuff. So when it comes to feature engineering, you will spend most of the time, almost 70% of the time doing this feature engineering. So it's always an iterative process. So you use some feature and build the model and see, and then you don't use those features and then build the model. So you generate new features, you remove the existing features, you alter some features. So you have to always do this in an iterative manner to identify what is the best feature for you. So feature engineering comes with practice and domain knowledge. I advise you to go ahead and see what are the other feature engineering techniques we can use in our model, and I wish you good luck on your next machine learning problem. Thank you.